This is the Geometry Unit 4 Test Prep video, Part 1. First, we're going to use the trig ratio, sine, cosine, and tangent to answer the following questions. We need to find the sine, cosine, and tangent for angles B and C. We know that using the SOHCAHTOA memory device, we know that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we start with angle B, the sine of angle B is the length of the opposite side over the length of the hypotenuse. So that's 36 over 85. The cosine of angle B is the length of the adjacent side over the length of the hypotenuse. So the adjacent side is 77 and the hypotenuse is 85. So cosine of angle B, 77 over 85. Tangent is opposite side over adjacent side. So the tangent of angle B is the opposite side, 36, over the adjacent side, 77. Okay, so now for angle C, the sine is the opposite over the hypotenuse. So 77 over 85. The cosine is the adjacent over the hypotenuse, 36 over 85. And the tangent is the opposite over the adjacent. So 77 over 36. So looking at our answers from part 1, what is significant about sine of B and cosine of C? Well, they're equal to the same value. And why is that? Sine is opposite over hypotenuse. So the side opposite of B is 36 and the hypotenuse is 85. Cosine is adjacent over hypotenuse and the side adjacent to C is 36. So sine B equals cosine C because the side opposite of angle B is the same side that is adjacent to angle C. And then, how are tangents of angle B and angle C related to each other? Well, if you look at tangent B and tangent C, they're reciprocals of one another. And that makes sense because opposite of angle B is adjacent to angle C. So when you switch reference angles, which the side that was opposite and the side that was adjacent switch. So number 2, a marksman aims at a target that is placed on a tower, so the target's elevation is 120 feet higher than the end of the rifle's barrel. His rifle is raised to an angle of 35 degrees above horizontal, and we want to find the distance that the bullet will travel in order to hit the target. And we can assume the bullet is traveling in a straight line. So here is an illustration of the situation. The angle is 35 degrees above horizontal. The target is 120 feet straight above the ground, which makes this a right angle. And then that's all the information we have. So using our sketch, we're going to use a trig ratio to solve for D, to find the distance the bullet will travel in a straight line. Well, we have the angle, and we have the opposite side, and we want to find the hypotenuse. So we have opposite and hypotenuse. And sine is the function that relates opposite and hypotenuse. Sine is opposite side over hypotenuse. So the sine of 35 degrees is 120. The opposite side over the hypotenuse, D, that's what we're solving for. Now if I multiply both sides by d, the d's will cancel on the left, and we get d times the sine of 35 equals 120. And then in order to solve for d, we can just divide both sides by the sine of 35 degrees. So we get that d is 120 divided by the sine of 35 degrees. So I open up my calculator and I do 120 divided by the sine of 35. Negative 280. That's not a very fun distance. So what's the problem? What did I do wrong here? My calculator starts off in radians mode, so I need to change that to degrees. And so if I click on the mode button here, here's degrees. So I need to move the cursor down and over to degrees and hit enter. And now I'm in degrees mode. So I can do second and then quit. And now if I re-enter 120 over the sine of 35, I should get a positive distance, 209.21. And those are feet. That's the end of part one. Go ahead and take a break, have a snack, drink of water, stretch a little bit, and then come back for part two. See you in a few.